Hi, my name is Megan Lauzon, and I will be presenting on analyzing a square kilometer of hybrid energy landscape within Minnesota. So, we'll start with the introduction of presentation, then go into so what. So, why should you guys care about a hybrid energy landscape? Some background about this, my research question. And then I'll further expand on what the idea of this topic is, calculations for how everything was determined, show some of the pictures as to how I chose a location, and then the results of selecting this landscape. So my project is looking at creating a hybrid energy landscape, and this is completely theoretical. Selected a single square kilometer and examined the amount of space that could be used for wind energy, how much could be used for solar, and then having some buffers for roads to protect the solar panels from vehicles that would be around. So why you should care about this creating hybrid energy landscapes. For one, we need to move away from fossil fuels. They pollute the environment, they contribute to global warming, they are a threat to biodiversity, along with fossil fuels are a finite resource. So eventually there won't be the quantity, or maybe they won't be as accessible as they currently are. Along with this, some information is the US currently gets 85% of its energy from fossil fuels. So imagine if that was all renewable instead. Additionally, we need to switch from fossil fuel energy, or like why we need to is using fossil fuels as a habit. It's built into our infrastructure, so there needs to be adjustments which will take time. The idea currently is that in the short term, fossil fuels are cheaper to use than converting to other technology. But in the long run, which one will be more feasible? And then finally, there is a lot of political power behind fossil fuels within the industry. So they have a lot of influence over what energy or where energy comes from within the United States. There, when using fossil fuels, there are prices and costs that you don't see when you're paying for that gallon of gasoline or fuel. So these include health impacts, so respiratory issues and issues with drinking water. Additionally, environmental degradations, which could be the loss of biodiversity or water pollution, air pollution, and such. And so these all come from having fossil fuels being extracted from areas, the transportation of them, and the burning of them. And so, like I said, biodiversity is threatened through the use of fossil fuels, through habitat loss by going to collect or harvest or mine for fossil fuels. Invasive or an exotic species along with pathogens can be introduced. The burning of fossil fuels is helping to create climate change, and so also the collection has a disturbance and degradation on these habitats. So and this can take place in both direct and indirect forms. And so, a little bit about wind turbines. They do more than just produce energy, they also create a suction of air to which has two different results. It can cool the earth when it's sunny out and the earth's surface is warming, but then they also can have a warming effect in the evening when the earth's surface starts to cool. And so this results in a stability within the earth's surface temperature, which could be very useful for agriculture, during, like, say, the summer in Minnesota when it gets really hot and those fields dry out, or in the winter or late fall when everything is starting to cool off and freeze, that will stay warmer, which could extend our growing season. And so solar is another renewable energy that is even better than wind. And so it additionally can alter the temperature of the Earth's surface. This happens primarily through the reflectivity of panels and the fact that they adjust the albedo of the Earth's surface. And so this is much more pronounced than wind energy, but it would be the impact would occur primarily when large scale solar was going to be used versus having small solar panels. So this effect could be controlled for and accounted for when creating these. And so like, through careful design, it can be prevented. And so for the state of Minnesota itself, the major sources of energy include coal, nuclear, and natural gas, which are all fossil fuels. So Minnesota is actually making a move to increase the amount of renewable energy that is being captured through wind. And so in 2005, there was a law that was passed that encourages the creation of wind turbines through community-based projects. And so these have to be owned by Minnesota residents, nonprofits, tribes, governments, or cooperatives, including electric cooperatives. Additionally, there have been difficulties with promoting these wind energy systems due to not due to the technology. It's there. The issue is the red tape with creating these projects for several companies, and some of the reasons are that there have been a flood of projects that have come in to create a wind turbine someplace, along with that the current system is not designed or is in need of repair. So that fits in with our infrastructure being designed for fossil fuels and not wind turbine or renewable energy. Additionally, a lot of the wind farms have not been adequately financed, and so to promote something, the state wants to know that there's the money to back it and that it's going to go through. So secondly, not the state alone, but several companies within the state have been working together through the E21 initiative to support the distribution of energy, renewables, and energy efficiency at fair costs. And so there are several different guiding principles that they have used. And so just a few of them are to provide universal access to electrical services, enable delivery of services and options at that customers value, and foster investments that optimize economic operational efficiency of the system as a whole, along with several others. And so for solar, in the case of Xcel, and this was just a few months ago, that they had the opportunity or received the approval to construct 3 large solar projects, and these will be approximately equivalent to the output of a mid-sized power plant producing 187 megawatts. And so this is enough to provide electricity to 41,000 homes. And so also the U.S. Treasury Department created a solar initiative program in 2009, and that made solar much more economical for people to create their own solar system or solar panels. And so these have, though they've made it more affordable, it doesn't guarantee that people will receive a grant, which can be very complicated but help reduce the cost greatly. So the area that I focused on is this one that you can see here. So it's a single square kilometer of Minnesota. So it's a center square, and it's located in the southwest corner of Minnesota. And so though it doesn't hold several turbines, there's 4 in there, and you can see that there's a few just right on the edges of it. It's located in a region that is used primarily for agriculture and is a high wind zone, along with having a lot of solar present. So it's a good place to try and do a hybrid landscape. And so my research question is how much electricity could be produced by a single square kilometer of a hybrid energy landscape within Minnesota? And so to begin, we used ArcGIS to determine the optimal location within Minnesota for wind energy. And in this case, it's located in primarily the southwest corner of the state. And that is actually where my little square is taken from. We also looked to see where solar was used, or where it was the strongest. So it's the insolation, so the amount of sun hitting the earth. And so once again, you can see that that's in that southwest corner of the United States. Though the solar panels that I'll be talking about in the future are using the numbers from the metro area. So I will actually be undercalculating the amount of energy they could produce. So those numbers will be just a little off when you see them in the future. And so here is the state of Minnesota, and once again in that southwest corner you can see the little kind of blue dots or the blackish line, and that is showing the turbines that currently have been constructed in Minnesota. There are a few spread out in northern Minnesota, but they're densely located down in this region. And so a zoom in of this, we used a fishnet of a square kilometer, to then focus in on what the landscape looked like. And so this little green dot in the center is the exact square that I selected, and you can see that is in a dense area of wind turbines. And so there it is once again. That is the square I selected. And so it really is, I looked through a lot of them, and this was pretty much an average with the number of turbines that were available or were within a region. Some have several, up to 19 is what we have counted. Others just have one. And so this really was a good combination of turbines and agriculture and homes in the area. So my calculations started for the wind, and we had the assumption of the capacity factor of 5 megawatt hours per kilometer squared, and then the net capacity factor is 30%. And so Minnesota's demand for wind power each year is 4,786 megawatts per year. And so from there, I was able to take the capacity factor with the megawatt hours of energy that can be produced and got 1.5, and then calculated the number of hours in a year, and combined that with the amount of wind energy that could be produced to get the 13.14 gigawatt hours per year. Looking at solar, we have an example of what's at the University of St. Thomas, and so it's our solar array, and it's a 40 kilowatt system, and a grant was written by students within the geography department for this system. And so this is output in real time. So this was over the course of late winter, and so you can see that the numbers are rising. It's estimated, or it's supposed to be 40 kilowatts. So we are right on track from talking with the engineers that help to keep track of this, and they say we're going strong. So now with our solar calculations, once again, it's a 40 kilowatt hour system per day, and so in the course of a year, as was provided by the state of Minnesota, is 56 megawatt hours per year. And so we have the dimensions of it, and then converting from feet to kilometers squared. And so to fill a square kilometer, we would need 2,900 and about 16 of the systems that are on the roof, or are intended to be placed on the roof. And so this means that system can produce 1,630 3.3 gigawatt hours per year per kilometer squared. So once again, how much energy is produced by the or is demanded by the state of Minnesota each year. And so in the end, you get that you would need about 20 or 30 kilometers squared of solar panels to power the state of Minnesota for a year. And so now, if looking back at kind of my project, if you were to have a single turbine that can produce 3 megawatts, and to have it run for 24/7 for a year, that would have an output of 7,884 megawatt hours. And so in the case of my system, there are 4 of them, and so that is about 31,536 megawatt hours being produced over the course of a single year within that single kilometer. Now for the solar panels, once again, use that 40 kilowatt hour per day assumption. It could be a little higher because it is in a location with a little bit more sun energy hitting the earth versus what's available in the metro. And so for this one, I got 146,941 megawatt hours produced within the square kilometer over the course of the year. And so this is with the assumption of the solar taking up about 90% of the square kilometer, as the rest would be used for the turbine footings, the road, and the prairie grass. And so that's what you get with that. And so the prairie grass, though it could be harvested and used to produce biofuel, I just decided to leave it alone and just not include it within the calculation. So it's space that can be used as habitat for other creatures. And so now comparing that to a square kilometer of monoculture with corn, that corn can produce about 110 megawatt hours of energy over the course of a single year. So the wind and solar within a square kilometer produces a much larger amount of energy. And so that total of the wind and the solar is 170,477 megawatt hours per square kilometer over the course of a year. And so now looking at how much energy the state of Minnesota demands each year, which is 4,768 gigawatt hours of electricity, you would need a total of we would need our square kilometer to produce it does produce the 178.5 gigawatt hours, which means that there would need to be a total of 27 of these hybrid energy landscapes throughout the state of Minnesota. Obviously, some will produce more and less depending on where they're located, so potentially you'd need a little bit higher number. But when you look at the total size, the number of square kilometers within Minnesota, there are 225,171 square kilometers. This includes water, so obviously you have a little bit less space, but these hybrid landscapes would use 0.12% of Minnesota's landscape. So it's a very small amount of space. And so finally, if this could go on, and future things to look into would be if all homes were converted to run entirely on electricity. They could still have a vehicle that runs on fossil fuel, but looking just at the homes, so no natural gas or anything like that, how much would the electricity demand of the state of Minnesota increase? And so then if those were to increase, how much more of these hybrid energy landscapes would be needed, and would that be feasible? It'd also be interesting to see the number of homes that are being provided with energy from that, in ways that these dense hybrid energy landscapes could maybe be expanded out. So by placing the solar panels specifically on a location of a home and putting the wind energy in the most optimal location. And so ways to spread out what we're looking at densely, but make it into little pockets. So that is what I looked at for my research. So I would like to thank the Department of Geography at the University of St. Thomas for all their help, and Dr. Laura. And so finally, my beautiful sunset with our wonderful wind turbines in the background.